Alright, so for today we're going to start dealing with rational expressions. In this box I've put all the skills that you should know from Algebra 2, and if you don't, then I hope this lesson will help refresh those. You should be able to find the domain of a rational expression. You should know that a rational expression is the quotient of two polynomials. You should be able to simplify rational expressions by reducing to the lowest terms. This may involve factoring both the numerator and the denominator. You should be able to add, subtract, multiply, and divide rational expressions. You should be able to simplify complex fractions. And last one, and I think it's kind of an important one, you should be able to simplify expressions that have negative or fraction exponents. Okay? Alright. This packet will help you kind of refresh most of these skills, not all of them, but most of them. Okay? Alright, so with rational expressions, you must remember that when you're trying to find domain is all the x values that will make that function work. So it'll be easier to find the values that will not make it work rather than list everything that does make it work. So since we're dealing with a rational expression, you must remember that you cannot have a 0 in the denominator because it's impossible to divide by 0. So what we're going to do to find the domain is you're going to set the denominator equal to 0. So you're going to set denominator equal to 0. So if we do x minus 2 equals 0, you're going to find out that x equals 2. What this means is that you can put any x value into this function, you're going to get a y value out of it, except when you put in 2. Now there's two ways that you can write domain, and I might ask different. So there's two ways that I'm going to accept, however, pay attention to which one I ask for. There's something called interval notation, which looks something like this. It will be from negative infinity all the way to 2. At 2, we're going to use parentheses because we don't actually touch 2. And then we pick back up at 2 and go to infinity. That's called interval notation. Okay? The other notation that you should be familiar with is called set notation, which says domain is the set of all real numbers except x cannot equal 2. And you need to be familiar with both of those notations, because in your test I may ask you, give me the domain in set notation, or give me the domain in interval notation. If you give me the correct domain but don't use the correct notation that I'm asking for, I won't count it wrong, I'm just going to take points off. Okay, so make sure you're familiar between the difference between interval and set. The way I remember is that an interval is kind of chunks, like an interval of time, so this kind of chunks and then picks up somewhere else. And the set is, I use the symbols to remember. This little bracket stands for set, so set notation. Okay? Alright, now we're just going to practice reducing expressions to its lowest terms. Okay? Notice that up here I underlined some of the skills that you're really going to use with this, which is factoring numerators and denominators. Okay? Alright, so for number 2, now, number 2, the numerator, take a look at it. Your highest degree is 3, and then you don't have anything but a constant. Do you guys remember what this is? What is this? This is a difference of cubes. And if you don't remember the formulas, you need to memorize them, and here they are. Difference of cubes is you're going to have an a value cubed, so let's say a cubed plus b cubed, where a and b are real numbers. So in order to factor this out, you take the cube root of the a value of the first value, so that will be a, and then you take the cube root of that value, so that will be b, and you add them. Okay? And you're going to multiply that by, well, what's going to make a times what is going to give you a to the third power? A squared. Now, b times what is going to give you b to the third? B. That's going to be all the way at the end, b squared. Now, the formula that we use for sum of cubes, okay, notice how this was positive. The next sign, you're going to change it and make it negative. And then you multiply the A and the B. So A, B. And the last sign is always going to be plus. Okay? Now, that's the... Did I just do sums? Sorry. Sum of cubes. Now, the difference of cubes is very similar. That will be a to the third power minus b to the third power. Is going to be still a and b, but instead of addition is going to be subtraction. And everything else looks very similar, exactly the same except for the symbol. So you still have a squared, you still have ab, you still have b squared. When it's a difference, it's obviously minus. Then you change the sign, so it's going to be plus. And the last one is always plus. Okay? So you can kind of use that pattern to remember them. If you don't know this, or if this is the first time you've ever seen this, you need to memorize them. Okay? So now we're going to apply them to this problem. So number 2, look at the numerator. You have a difference of cubes. What's the cube root of x to the third? Well, it's going to be x. What's the cube root of 8? 2. So it's going to be x minus 2 times x squared. Switch the sign, so it's going to be plus. What's 2 times x? 2x plus 4. Questions on that before we keep going? All we did was apply the formula. Okay? What's going to happen in the denominator? You can factor out an x squared, which leaves you with x minus 2. Correct? Now, at this point, you're going to recognize that something should cancel out. So you're left with x squared plus 2x plus 4 all over x squared. And that's going to be your answer, because the numerator will not factor out. You can try to, but I promise you it's not going to factor out. Okay? Now, can you guys tell me what the domain would be of this in set notation? All real numbers except x cannot equal 0. I agree, but we're missing a value. And I figure that some of you guys must have forgotten this. To find domain, you must use the beginning. You must use the first equation. In other words, before reducing. Okay? So we're going to be using this. So that means that x cannot be what as well? 2. Okay? So you need to remember, and yes, so you're getting a little ahead of yourself, but yes, that's why. Very good. Okay? There is a whole press in there, and we'll talk about it, what that means. Okay? In upcoming lessons. But one thing, like again, I need to remind you is that what I typically like to do is I like to factor everything out, and then with that find the domain, write the domain, and then go and finish my problem and reduce it. That's what I typically like to do. Because if you do this and then you go here, you might forget the whole domain that you need to use this one for the domain, and you're going to tell me that just x cannot be 0, and that's not going to be a complete representation of what the real domain is. Can also do that too. Okay? Alright, questions on that problem? Alright, so number 3, I want you to try it on your own. Reduce it, and find the domain, please. Alright, check your answers. For when you reduce the expression, you should be able to get negative 2 over x plus 3. And for the domain, I went ahead and wrote the domain in both types of notation. The reason why I did that is because you have several values this time where you cannot have an x value, so you're going to have more of these intervals. Okay? Questions? Good? Alright, let's go ahead and keep going. Alright, so now we're gonna move on to actually operations using rational functions, okay? So the first one is multiplication. My suggestion is before you start multiplying things out, again, I need you to factor things out. Because if you start multiplying things out from the beginning, then it's going to make just the algebra tougher for you. There's nothing wrong with it. You can multiply it out if you want to. But again, then it's going to make the algebra tougher. So what I would do is I first factor everything out. So up here you should be able to see that this should be x minus 1 times x minus 1 over x times x squared minus 1. And the second fraction you should be able to factor out a 4. That's x squared plus 1. I'm sorry, this should be a plus 1. Down here, I made a mistake. And the denominator of the second fraction should be able to factor out into x plus 2 times x minus 1. The reason why we do this is because now you can cancel things out. Okay? You should be able to recognize that the x squared plus 1s are going to cancel out. X minus 1 is going to cancel out, leaving you with 4 times x minus 1 over x times x plus 2. Okay? What is the domain of this? Zero plus or minus 1 or negative 2. Okay, I want you to notice I wrote them all out of order, so I'm going to rewrite this because they need to be in order. Okay, x cannot equal negative 2, negative 1, 0, and 1, correct? So you must write them. Okay, if you write this first just to kind of give yourself an idea, but they need to be in order. And if you wanted to write this as interval notation, you're going to have a lot of intervals, okay? But you will have 1, 2, 3, 4, 5, 8 intervals? No, 6 intervals, okay? So just be familiar with it. More than likely for this problem, I would ask you set notation, okay? All right, questions with that one? All right. Let's look at number 5 then. Now you have division. What must you remember about division? Okay, you're going to need to flip the second one. So what I will do first is I'm going to rewrite this as x plus 3 over x squared minus 4. But instead of division, I'm going to switch to multiplication, and I'm going to do the reciprocal of the denominator. In this case, it's going to be x to the third minus 8 over x squared minus x minus 12. And now factor things out. So on the first fraction, you have x plus 3 on the numerator, and the denominator should become x plus 2 times x minus 2 because you have a difference of squares. On the second one, we have a what? Difference of cubes. Okay? So that means that it's going to be x minus 2 times x squared plus 2x plus 4 all over. The denominator is going to factor out to be x negative 4 and x plus 3. Okay? At this moment, what I would do is actually find the domain. So let's go ahead and do that. What's the domain? All reals except x cannot equal. Let's go ahead and write them in order from lowest, so from least to greatest. Negative 3, negative 2, positive 2, and positive 4, correct? Alright, now we're going to go ahead and reduce. This is going to cancel out. That's going to cancel out. So you're left with x squared plus 2x plus 4 over x plus 2, x minus 4. And that's your answer there. Because the numerator is not going to factor out, correct? Is this bringing back Algebra 2 skills? Alright, so try number 6 on your own, and then pause the video at this moment, and then come back and check your work. Alright, so go ahead and check your answer. After factoring everything out, I reduced to be x plus 6 times x plus 1 over x squared. And your domain should be all real numbers except x cannot equal 0 or 6. Okay? Questions? Concerns? We're good? Alright, let's move on. We're almost done. Alright, the next operation that you need to be comfortable with is addition and subtraction. And you must remember that when you're adding and subtraction rational expressions, you must have what? In common. Common denominators. So for this one, don't worry about finding the domain. I just want you to do the operation. Okay, so we can just go ahead and move on. Number 7, you're lucky that it has common denominators, right? So that means this becomes 2x squared minus 4 plus x plus 3 all over 2x plus 5. Correct? Now, if we combine like terms on the numerator, we're left with 2x squared plus x minus 1 over 2x plus 5. Could this be factored further? Yes, you should be able to. So let's try it. On the numerator, what is it going to be factored to? 2x minus 1 and x plus 1. I agree. And the denominator stays as 2x plus 5. As you notice now, nothing is going to cancel out, so this is your answer. Questions on that one? Good. Alright, so number 8. Again, now I want you to, don't forget this. When you have a minus, it's going to make a difference. Okay? Because in reality, what this says is that you have minus this entire thing. So what are you gonna have to do with that negative minus sign? You're gonna have to distribute it in. So when you're rewriting this is gonna say on the numerator x minus 3x minus 2 all over x minus 3. Okay, so remember, when that negative will make a difference, and if you forget to distribute it, you're gonna get the wrong answer. Okay. All right, so we're gonna combine like terms, so this becomes negative 2x minus 2 all over x minus 3. We're gonna just do one last thing and factor out a negative 2, so this becomes x minus 3. And that should do it. It's not going to simplify any further. Alright, number 9 and number 10, I was not that nice, so you're going to have to get common denominators on your own. Okay, so what's going to be the common denominator on number 9? So we're going to have x plus 4 and x minus 2, correct? Now, in order to achieve that, the first fraction, you're going to have to do what to the x minus 3? Multiply by x minus 2. And on the second fraction, you're going to have to multiply the x by x plus 4. Now, I know that on the previous problems, we've been kind of leaving everything like this. Except, I have a problem here. I have a feeling that if we distribute things out, and then refactor things out, something might cancel. So keep that in mind when you're doing addition and subtraction. Okay? So what I'm going to do is I'm going to factor things out and combine like terms. and then see if anything will cancel. Okay, so on this first set of monomials here, I'm going to distribute, and it's going to become x squared minus 5x plus 6 plus x squared plus 4x all over. I'm going to leave the denominator alone. I don't need to mess with that. Okay? Alright, so now on the numerator, now you're going to see that you have x squared plus x squared, that's 2x squared. Negative 5x plus 4x, that's going to be negative x plus 6 all over x plus 4, x minus 2. Okay? Do you guys see why I went ahead and FOILed everything out? Now, looking at the numerator, is that numerator going to be factorable? Here? Well, if you cancel things out, you go right back to that. So it will be kind of counterproductive. Okay? So you have to go ahead and distribute everything else so that you can reduce to get to here. Now, is that 2x squared minus x plus 6 going to factor out? Is it? I don't think so. I don't think so, right? I don't think so. Okay? So that means that this one, your answer doesn't, this is as simple as it's going to get. Okay? I don't think it will, because of that 2x in front. Okay? Alright, questions? Alright, you want to try number 10 on your own? Alright, try number 10 and then come back and check the answer. Alright, so check your answer. You should be able to have been getting the common denominator of x times x squared minus 4. And when you combine like terms, you get on the numerator x to the third minus x squared plus 4. And on your denominator, you get x times x minus 2 times x plus 2. Okay? Notice how the domain, I've already kind of found it for you, so I think by now you had enough practice. But for all of them, I went ahead and found the domain. I told you what x could not equal to. Okay? Alright, number 11. It says perform the indicated operation and leave your answer in factored form. Okay? Alright, so before you try to even look into getting and multiplying this by that to get common denominators, what I'm going to do is I'm going to factor them out to see if they have any factors in common before I make my life more complicated. Okay? So the first fraction, it's going to be x over x plus 2 times x plus 1. And the second fraction, it's 2x minus 3 over x plus 1 times x minus 1. Now, as you can see, they both have the x plus 1 in common, so you kind of made your life a little easier there. Okay? So that means that this one, in order to have the common denominator, it's going to be x plus 1 times x minus 1 times x plus 2. That's going to be the common denominator between both of them. This first fraction has the x plus 1 and the x plus 2 and the x plus 1, so all you're missing is the x minus 1, so it's going to be x minus 1 times that x. The second fraction, you have the x plus 1 and the x minus 1, so you're going to need to take that 2x minus 3 and multiply by x plus 2. Okay? Alright, from here you are going to have to actually simplify this and distribute everything to see if things cancel out. So x times x is x squared minus x plus 2x times x is 2x squared. 2x times 2 is plus 4x minus 3x minus 6 all over x plus 1 times x2. Going to come up here. Combine like terms, 2x squared and x squared, that's 3x squared. Negative x, negative 3x plus 4x, that cancels out, so that's minus 6 over x plus 1, x minus 1, x plus 2. This should further, on the numerator, if we factor out a 3, then you have x squared minus 2 over x plus 1, x minus 1, x plus 2. And lastly, x squared minus 2 should factor out to be, no it doesn't. I was like, wait a second, no it doesn't. That's it, that's as simple as it gets. So that means our final answer should be here. Okay? Technically, you could factor this to be x plus square root of 2 times x minus square root of 2, but I want you to leave it as whole numbers. Okay? Alright, questions on that? Where? I always do that. Sorry. Alright, last questions. They're on the back. And 12 and 13 look difficult, but in reality they're not. I'm just throwing in there several operations at the same time. Okay? What I would do first is, number 12, I have an addition of two fractions. Let's go ahead and make it into common denominators, and then we'll go from there. So the common denominator is going to be 2x. So I'm going to have to multiply the first one by x, and I'm going to have to multiply the second one by 2. So 3 times 2 is 6. Okay? And we're lucky enough that the second one is already just in one fraction. So now we have fraction divided by fraction. So remember, you keep this first one the way it is, so x plus 6 over 2x. You switch to multiplication and you do the reciprocal of the second one. And you get the following. You get 4 times x plus 6 over 2x times x plus 3, which you can reduce to 2 times x plus 6 over x times x plus 3. And you should be done at that point. Number 13, same. So let's go ahead on the first fraction, on the numerator of this original problem. We're going to get common denominators over x all over. Okay, the common denominator is going to be x minus 1 over x minus 1 minus 1 over x minus 1. That's going to be 2 minus 3x over x. Well, x minus 1 minus 1, that's going to be x minus 2. And all over x minus 1. So we're going to simplify this to be 2 minus 3x over x, switch it to multiplication, and change it to x minus 1 over x minus 2. Which is, and then, I'm going to go down here. X minus 1 times 2 minus 3x over x times x minus 2. I'm just going to rewrite this to make it look a little better. Going to factor out a negative from this one, so it's going to be negative 3x minus 2 times x minus 1 all over x times x minus 2. And you should be done right there. I would accept if you leave it like this one on top. I will. I don't know. It makes me happier for some reason to take out that negative. Okay? Alright. And that's it. That's all I got for you. Well, actually, this 13 asks you, what values can x not be? 0, 2, but you're also missing a value. What other value can x not be? It cannot be 1. Why? Correct. So notice, even from the beginning of the problem, if you were to put in a 1 in there, that's going to be 1 minus 1, which is 0. Can you have anything over 0? No. So that means that your domain should be all real numbers except x cannot equal 0, 1, and 2. Okay? Any questions over today's lesson? Okay? Homework is on that worksheet. There is 20 questions on there, and some of them are challenging. Okay?